Welcome to the lecture session. In today's lecture, I am going to discuss about what is a unit step function. The unit step function, it can be also called as a Heaviside function. The definition is the unit step function u of t minus a, or the Heaviside function h of t minus a is defined as follows. So u of t minus a will be 0 when t is less than or equals to a, and it is 1 when t is greater than a. This is the definition of the unit step function. So coming to the properties, we have the properties like this. Unit step, that is L of u of t minus a, is given by e power minus as by s. And the second property is, if L of f of t is f of s, then L of f of t minus a into u of t minus a will be e power minus as into f of s. Supposing if f of t is f1 of t when t less than or equals to a and f2 of t when t greater than a, then f of t can be written as f1 of t plus f2 of t minus f1 of t into u of t minus a. Next property says, if f of t is f1 of t when t less than or equals to a, f2 of t when t varies between a and b, f3 of t when t is greater than b, then f of t can be written as f1 of t plus f2 of t minus f1 of t into u of t minus a plus f3 of t minus f2 of t into u of t minus b. So now let us solve some problems by using the properties. Find the Laplace transform of e power t minus 1 plus sin t minus 1 into u of t minus 1. So it's given, let's consider L of e power t minus 1 plus sin of t minus 1 into u of t minus 1. Now we know that if L of f of t is f of s, then L of f of t minus a into u of t minus a will be e power minus as into f of s, as t tends to t plus 1. F of t will be e power t plus sin t. So L of f of t will be L of e power t plus L of sin t. So L of e power t is given by 1 upon s minus 1, and L of sin t is given by 1 upon s squared plus 1. This is a f of s for e power t plus sin t as t tends to t plus 1. Now the second question. L of t cube plus t squared plus t plus 1 into u of t plus 1. Consider this L of t cube plus t squared plus t plus 1 into u of t plus 1. We know that if L of f of t is f of s, then L of t minus a into u of t minus a will be e power minus as into f of s. So here a is minus 1 and f of t plus 1, we have to consider f of t plus 1. So t cube plus t squared plus t plus 1, when t tending to t minus 1, so f of t will be t minus 1 whole cube plus t minus 1 whole square plus t minus 1 plus 1. Simplifying, that is a minus b whole cube is a cube minus b cube minus 3ab into a minus b form. So it is t cube minus 3t square plus 3t minus 1, and t minus 1 the whole square is t square minus 2t plus 1 plus t minus 1 plus 1. So here minus 1 and plus 1 cancels. Here also plus 1 and minus 1 cancels. And we have 2t, and this is 4t, so it will be 2t. T cube minus 2t square plus 2t. So L of f of t is L of t cube minus 2 times of L of t square plus 2 times of L of t. That gives us 6 by s power 4, that is 3 factorial by s power 4, and 2 factorial by s cube. So already 2 is there, so it is 4 by s cube plus 2 into L of t is 1 by s square. That gives us 2 divided by s square. Therefore, it is equal to e power s into 6 by s power 4 minus 4 by s cube plus 2 by s square. So this is the answer. Let's see the next question. F of t is given by sin 2t when t is varying between 0 to pi and 0 when t is greater than pi. As per the properties which we have discussed, f of t when f1 of t less than or equals to a, f2 of t when t greater than a, f of t can be written as f1 of t plus f2 of t minus f1 of t into u of t minus a, where a is, in this case, it is pi. So, f of t will be sin 2t plus, here f2 is 0, 0 minus f1 is sin 2t into u of t minus pi. So f of t will be sin 2t minus sin 2t into u of t minus pi. Here L of f of t will be L of sin 2t minus L of sin 2t into u of t minus pi. Let us keep this as it is, and first we'll determine L of sin 2t, that is 2 divided by s squared plus 2 square, that is 4. Now let us consider this part, that is L of sin 2t into u of t minus pi. So here L of f of t is f of s, means L of f of t minus a into u of t minus a is e power minus as into f of s, where here a is pi, so f of t minus pi will be sin 2t. So as t is t minus pi, so f of t will be sin of t plus pi, t plus pi it is, so sin of 2t plus 2 pi, and since it is a periodic, 2t plus 2 pi, it will become sin of 2t. So L of f of t is L of sin 2t, that gives us f of s is 2 divided by s squared plus 4. So now we need to combine the two terms. One is f of s, that is this part. Another part is this. So we have to apply this. So L of sin of 2t into u of t minus pi is given by e power minus pi s into 2 divided by s squared plus pi. Now we need to take this along with the previous result. What was the previous result? We have, this is the previous result, that is 2 divided by s squared plus 4, and this is also 2 divided by s squared plus 4, and we have applied for a unit step function. So this 2 divided by s squared plus 4 is common, and for the previous one it was 1 minus e to the power of minus of pi s. This is the result we are getting it. We can see here 2 divided by s squared plus 1 minus L of sin 2t into u of t minus pi So this on simplification we are getting 2 divided by s square plus 4 into this u of t minus pi. If we do, it will be e to the power of minus pi s multiplied. Then we get e power minus pi s into 2 divided by s square plus 4. So this on subtraction with the previous one, that is 2 divided by s square plus 4 minus 2 into e power minus pi s divided by s square plus 4. On taking the 2 common and s square plus 4 in the denominator common, we get 1 upon 1 minus e power minus pi s. So this is how we can solve the problems for discontinuous functions as well as the unit step function or the Heaviside function. Thank you. In the next lecture, I am going to discuss some more problems on the unit step function for the discontinuous functions. Thank you.